find the load resistor. Obviously, 6 here is my what? Load resistor. Meaning, in place of this diagram, I have what? 6 ohm resistor. Now, how do I get this out? Meaning, the equivalent resistance in the circuit. And how do I get this I short circuit? That is the current flowing through 6 ohm resistor. I said earlier on that the steps remain the same. The steps remain the same. Meaning, having identified your load resistor, next thing is what? Draw your circuit. But by the time you draw your circuit, you are short circuiting the branch, you have your load resistor. Now, let's label the branch as branch AB. Now, let's draw our diagram. That becomes this. We said from here, identify your load resistor. This is my load resistor, which is 6. The next thing is what? Short circuit the branch. You have your load resistor. Then we denoted the branch as AB, meaning we short circuited AB. So this is what we have. Now, the next step is what? The next step is what?
Identify your short
circuit. The next step is what? Find I short circuit. Find what I short circuit. Now, how it works for question like this is that, from here, I want to get I short circuit. First thing first, identify, is this a voltage source or a current source? This is a current source. This is 6 milliampere. 6 milliampere. Meaning, in place of voltage, the usual voltage that we do, we have current there. Let me just say this. What it means is that generally, when you encounter a question like this, you want to calculate your I short circuit. What you are going to do, up to this level, what you are going to do is that you are going to withdraw another circuit diagram. You are going to what? Withdraw another circuit diagram. You withdrawing another circuit diagram. This is what you should watch out for. The resistor that does not have source. The resistor that does not have source. Meaning, when we say source, we are referring to what? Either current or voltage. I get what I'm saying? From here, you are withdrawing another diagram. The next diagram that you are drawing, you are not including the resistor that does not have what? Source. By source, you are referring to what? Either current or voltage. Either current or voltage. Now, this is what I'm going to do. Let me denote this as 1, 2, 3, 4. The question is, me drawing this next diagram, the resistor that will be included will be what? Out of 1 to 4, it will be what? 3 and 4. Yeah, who said that? 3 and 4 is correct. 3 and 4. Are you getting the idea? He said, you are lost, right? Don't worry, you get it. I want you to, it's not as if I can't draw this diagram next, but I just want you to understand what you are doing. Now, up to this level, up to this point, we said you can obtain the value of your short circuit, meaning you can obtain the value of ISC from this diagram. I get what I'm saying? Yes. You can obtain the value of ISC from this diagram. Meaning, you are going to draw another new diagram from what you have already. Now, the idea is that, looking at this diagram, the next diagram you are drawing, you are not including the resistor that does not have source. When we say source, it means different things. Your current might be a source, your voltage might be a source. I get what I'm saying? Yes. Your current might be a source, your voltage might be a source. Now, from here, and overall, we have 4 resistors. We have, this is the first one, this is the second one, this is the third one, this is the fourth one. Now, implementing that idea that says that we are not including the resistor that does not have source. Now, what will be the resistor that you will be including here?
1 and 2.
1 and 2. Yeah. 1 and 2. Meaning, the one that you will be including there was 3 and 4. And you might want to ask, does this 3 has a source? The question is yes, it does. It does. Now, this will bring you back to the introductory aspect where we did when we define branch, node, junction. From your circuit, if you have something like this, say this is A, this is B, this is C, this is D, this is E, this is F. Now, say you have this current, call this current I1, call this current I2, call this current I3. You know, I2 and I3, I1 and I2, they are entering junction B, right? By the time they get to junction B, they are going to enter junction branch BE, and we are going back to Kirchhoff's law. This is KCL, right? By KCL, meaning your cubic sum of current entering a node is equal to your cubic sum of current leaving that node. Meaning that I1 plus I2 is equals to I3. But my question is that now I have how many branches here? I have branch AF, I have AB, BC, CD, EF, what else? AB, BC, CD, DE, EF, and FA. Now, how many branches is this? This is 1, 2, 3, 4. 1, 2, 3, 4. Then BE. You also have BE and BE. Now, these 6 branches. You know, the current flowing through these 6 branches, they are just 3. True or false? Do you agree with me? These 6 branches that I have here, the current that is flowing through these 6 branches is just for 3. And they are what? I1, I2, I3. Now, what I want you to do for me is that for I1, I2, and I3, let's identify the branches that I1 is flowing through from this circuit. That's what?
EF, FA, AB.
The branches that I1 is flowing through from this circuit diagram, that's what? EF, FA, AB. Yeah, that's correct. EF, FA, and AB. Branch for I2, that's what? What do you call it? DC, CD, and DE. DC, BC, CD, and DE. Then lastly, what branch is I2 flowing through? Only BE, just BE. Right? Now, when we said that initially, when you were drawing your next diagram, can you recall what I said? When we drawing your next diagram, don't what? Include the one that doesn't have source. I am not saying that they are what? 1 and 2. Now, I said, you might be wondering that these 2, this 3 2 does not have source. But I'm not saying that it has source. Now, the question is, what is this source? I get what I'm saying? What is this source? And this source is what? I shall circuit. Now, apply the same idea here to this. Is that correct?
Yes.
You are not getting what I'm saying?
No.
You are not getting at all.
At all.
Now, from here, I said, any questions so far from this place? Any question?
No.
No question, right? Now, you know the criteria when you want to draw your next diagram. And it is what? I want the answer together.
We don't add the one that does not have source.
The one that does not have source, right?
Yes.
Now, from here, you know, from this diagram, we said this is I short circuit, right? Yes. This is I short circuit. We are interested in getting I short circuit. You know, from here, what this means is that this I short circuit, this branch, just relate this guy from here. Relate this to what we've done here. You know, the current that's flowing through branch AB, let's denote this as C, D, E, F. We are relating AB, C, D, E, F to what we learned here now. Meaning that this current that we are looking for, this guy, this I short circuit, you see the same thing, you see the same current that's flowing through what? AC. Are you get what I'm saying?
Yes.
Meaning that when we join your circuit, you are including this guy. Why? Because it has a source. And the source is what? I short circuit. I short circuit. Meaning this I short circuit is flowing through this branch, through this resistor. I'm including it. I get what I'm saying?
Yeah.
This ISC is flowing through this what? Resistor. I'm including it in my next diagram. I get what I'm saying?
Yes.
It's also flowing through this place, but I don't have a resistor. So I don't have business with that. Hope you get what I'm saying?
Yes.
Moving on, this guy, this is 6 milliampere. It is flowing through this what? Branch.
C.
It is flowing through branch EC, also flowing through branch F.
FE.
What is this? This is F. Also flowing through what? Branch FD. Then we don't have resistor yet, so I'm not, obviously, that won't be considered. Then, of course, this current, this ISC and this guy, they are entering this place. This one also has the source. I get what I'm saying? So now, when we now say that drawing our next diagram, we are not including these two. Are we correct? Yes. We are correct. Correct. Because it does not have a source. That's what I'm trying to let you know. It does not have source. It does not have source. Now, meaning that drawing your diagram, you have this guy. What we label A, B, C, D, E, F. That will be your next diagram. That will be your next diagram. So what this means in general is that, say you want to calculate current, given any number of loops. Let's say 2 loops, 3 loops. Those loops must have at least a source in it. This source, it might be a current source, it might be a voltage source. Right? Now, say this is loop 1, this is loop 2, this is loop 3. Meaning that I want to get this I short circuit. I would have used this circuit diagram if there was if I have a source here, and even I have a voltage source or a current source, I will make use of this circuit diagram to get my I short circuit there. I get what I'm saying? Meaning loop 1 is out of it. Yes. And why is loop 1 out of it? It does not have a source. Yes. It doesn't have either voltage source or current source. Yes. But check loop 2. Loop 2 is the current that we are calculating, which is I short circuit. Now, check loop 3. What do you have here? 6 milliampere, meaning you have a current source. That is the next diagram. This is it. You already know why you excluded loop 1. Because loop 1 does not have what? A source. This source is either a voltage source or a current source. Right? Yes. Then also take note that this ISC, this current flowing through this branch, which is ISC. You see the same current flowing through 2 ohm resistor. True or false? True. Now, to get ISC, use current divider rule. Consider this diagram. Consider this diagram. Say this is I. Say this is R1. Say this is R2. Current division. Consider this diagram. Say you have this. This is I. Let's say this is I. This is R1. This is R2. Now, you must figure 1. Find the current in R1 and find the current in what? R2. This circuit diagram, you have R1 and R2, right? And you want to calculate I of R1, meaning you are interested in what? R1. But at the moment now, your interest is what? To know the current in what? R1 and not R2. Are you know what I'm saying? Yeah. Mm-hmm. You calculate R1. You calculate the current in R1 and you calculate the current in R2. Now, let's calculate the first current, which is what? IR1. Meaning, solving this guy, you are interested in knowing the current in what? R1 and not what? R2. Now, current division rule, how it works is that the one you are not interested in over the one you are not interested in plus the one you are interested in multiplied by the current that you have here. So that becomes what? Which one am I not interested in calculating this guy? Meaning R2 over R2 plus R1, only to bracket the current source I. Similarly, calculating IR2, that becomes what? R1, which I'm not interested in, plus R1 plus R2, only to bracket I. Only to bracket I. So this same idea, this is what we are implementing to this question. I get what I'm saying? This same idea, this is what we are implementing to this question. And this question is, I want to get what? The current of ISC. You know, the current of ISC, you see the same thing as calculating the current of 2 ohm resistor. True or false? True. True. Because we said from what we've learned or from what we've seen, we said this ISC, see the same current flowing through this guy. Through this guy. Meaning from here, you can just say that ISC, you see the same current flowing through what? 2 ohm resistor. By the time you know 2 ohm resistor, the answer is still ISC that you are looking for. Now the question is, how do you get this 2 ohm, the current of this 2 ohm resistor? Current divider rule. And by current divider rule, it says that the one you are not interested in over the one you are not interested in plus the one you are interested in times the current you have here. So that becomes what? Only 2 brackets. 10 over 10 plus 2 multiplied by what? 6. That's it.
5 ampere.
That's it.
5 milliampere.
That's what? 5 milliampere. Yeah, that's the answer. Applying current division rule, meaning any value you get for I of 2 ohm resistor is still the same value for I short circuited. Now let's solve for I of 2 ohms. That becomes what? Applying current division rule.
That will be 10 ohm.
10 divided by 10
plus 2.
plus 2. What is bracket? 6 milliampere. 10 over 12
times 6.
times 6. 6 go here, 1, 6 go here, 2.
10 over
Therefore, I of 2 ohm resistor is equals to 10 over 2, which is equals to 5 milliampere.
2. Type sheet type.
That is I of 2 ohms. I of 2 ohms is equals to 5 milliampere, which implies that ISC is equals to 5 milliampere. Now, out of these 3 parameters in Norton's theorem, which are what? I short circuited, the load resistor, and the equivalent resistance. We've gotten 2, right? We already know the value of 2, we found it. The first one is what? This I short circuited, we already know it, right?
Yes.
Then the load resistor itself, we know the value from the question. Now, let's solve for R. Let's solve for equivalent resistance, meaning R. Then from here, meaning that your equivalent resistance, you know what it means now? Your equivalent resistance, you are only considering the resistor you have left after removing your load resistor. Get my point? Meaning you are considering 1, 2, 3, and 4. Now let's draw the diagram for that. This is your diagram. This is your diagram. This is 8 ohms. This is 2 ohms. This is 4 ohms. And this is 10 ohms. Right?
Yes. Equivalent resistance is 6.
Now from here, looking at this circuit diagram, the task is you want to get this R, meaning the equivalent resistance, nothing equivalent resistance of this circuit. That's what it means. Now, how do you solve this? You know, unlike the first one, in parallel, multiply then divide. But in this case, what are you going to do?
This series is series.
8 and 4 is a series.
8 and 4.
8 and 4 are 10 and 2.
8 and 4 in what?
Are parallel to 10 and 2.
Okay, 8 and 4 are parallel
To
to
10 and 2.
10 and 2. Are they parallel or are they in series?
8 and 4 are in series.
Okay, 8 and 4 they are in series.
They're not parallel to 10
Eight-
and
Alright. 8 and 4 they are in series. 2 and 10 they are in series.
Yes.
And both of them they are parallel to each other. Now, meaning that from here, this is my diagram. I can have my diagram in simple terms by saying I have this. Right?
Yes.
This is 8 ohms. This is 4 ohms. This is 2 ohms, and this is 10 series. This and this are in series.
Yeah.
This and this are in series. Call this one. Call this 2. 1 is in series. 2 is in series. 1 and 2 they are parallel. Meaning 1 and 2 they are parallel. Or just say this is A. Don't let us use 1 and 2. Let's say this is A, this is B. A and B they are parallel. Meaning to get the value of R, you have to solve A and B parallel. Meaning that R is equals to A parallel to what? B. So now the question is, what's the value of A? What's the value of B? The value of A is what? 12. The value of B is what? 12. The value of A is 12. The value of B is what? 12. So from here, let's solve. Meaning C B is parallel to the resistor of branch E F. Now let's solve for branch CB. What's our answer? 8 ohms plus 4 ohms, which is equal to 12 ohms. Let's solve for branch EF. What's our answer? 10 ohms plus 2 ohms, which is equal to 12 ohms. Therefore, R, which is equal to this, becomes what? 12 times 12 divided by 12 plus 12. Right?
Yeah.
So this is what? 144 over 24. 6. Then R is equal to what? 6. R is equal to what? 6 ohm resistor. R is equal to what? 6 ohm resistor. Meaning, lastly, what are we going to do? We call your Norton's equation, or you say Norton's formula. Then by Norton's formula, before then, try to, these values that you've gotten, try to draw Norton's equivalent circuit. I get what I'm saying?
Yeah.
Try to draw Norton's equivalent circuit. ISC. This is R, and this is R. Now let's substitute. My ISC is what?
5 milliampere.
5 milliampere. 5 milliampere. My R is what? 6 ohms. Then my load resistor is what? 6 ohms. From Norton's formula, we have that I is equals to R all over R plus R all into bracket ISC. Substitute. Meaning I, which is equals to I of 6 ohms, is equals to 6 over 6 plus 6 all into bracket 5, which is what? 1 over 2, meaning 0.5 times 5, and this is equals to 2.5 milliampere. That's the answer. Given a complex circuit, right? Like what we have initially, right? Given a complex circuit, we analyze the circuit, we reduce it to Norton's equivalent circuit, or you say Norton's equivalent diagram. Then we obtain the value of I short circuit, the value of load resistor, right? Then the value of the equivalent resistance. Then you substitute that into your Norton's formula. Then we got our final answer to go 2.5 milliampere. Now, in general, what this means is that given any complex circuit, first thing first, identify your load resistor, and the steps remain what? The same, constant. Nothing is changing. You know, I've always said this always. Given a particular subtopic, but mostly in this our engineering courses, you just have to unleash the step. By the time you know that step, nothing is changing. Nothing is changing. So, meaning as we go advance, the steps remain the same. So that's how it works. So you got 2.5 milliampere.